In this tutorial, we're going to use automatic tracking in the Cine Analyzer's track and measure module. So the first thing I'm going to do is I'm going to upload a Cine file. Now, this is an automotive crash test Cine file where we have a car seat test, an infant car seat test here. And if you take a look at this Cine file, you can see well-defined quad markers on the head. And you can also see a marker at the elbow, or rather a feature, and also at the ankle. So all these things can be tracked in the Cine Analyzer package. So the first thing we're going to do is we're going to calibrate this Cine file, okay? So we're going to actually, in this case, assume that the quad marker has a diameter of exactly 2 inches here, all right? And this is purely for training purposes. So if I click on calibrate, I can go ahead and click the leftmost side of the quad marker. I can hold Control and click on the arrow key to get really fine control, then click enter, and then I can move over to the rightmost side of the fiducial marker and click enter. All right, then I can say that this is exactly 2 inches here, and then click OK. All right, so now we can go ahead and do some tracking on anything that moves in the plane of this quad marker. So it's valid to use the quad marker itself, and let's pick an arbitrary feature. Let's go with these two joints here, these little black marks on the ankle. All right. So to do auto tracking, all you have to do is click on track. And by default, the auto tracking feature is enabled. And we just have to add objects. So if I click add object here, I will click on the very center of the quad marker. All right, click enter. And then I will also add another object, and I'm going to go ahead and click this feature on the ankle itself. All right, so I'm going to click the very center of that as close as I can get and click enter. If I right click the object and click edit, I'm going to go ahead and name the first marker head. I'm going to right click the second object, and I'm going to edit that and call it ankle. And I'm looking at my template size here, and if you notice, this red square doesn't quite go completely around that fiducial marker. So I'm going to go ahead and right click, open the dialog, and I'm going to go ahead and increase the size of the template from 31 to 41 and click enter. And you can see that that entire marker is surrounded by that red bounding box, which is great. Okay, and I'm looking at the marker for the ankle, the position, and this is going to be my my track template here, which looks good. So now all I'm going to do is just right click one of the features, or the objects rather, and I'm going to just click process all. And what process all does is it automatically tracks these two markers or features through every frame of the Cine file. If, for example, you want it to remove points or edit the table in any way, you can go ahead and right click on the table. You can jump to a specific frame. You can remove selected points. You can go ahead and remove all points, or you can remove points before or after a specific frame that you click on. So for example here, if we were to go ahead and right click here, and let's just go ahead and remove all the points from this particular object. This is the head. You'll see that we are left with just the ankle being tracked, and it is completely cleared, and you will not get that data back. So if just be careful with that. Okay. Before we continue, I just want to point out that the fundamental tracking algorithm relies on this template image, for example, this fiducial marker here. As we take a look, we see colored boxes. Okay, that's our template image. And the way the algorithm works is essentially we do normalized cross correlations of this template image within this black box, which is our search area. So essentially what we're doing is we're taking that, whatever's in that color box, this smaller image, and we're searching for it in the next frame within this black box area. All right, and if you notice, the frame rate is high enough so that the object doesn't jump outside of that search area, so that's gonna work well for us. However, if you had a situation where you had a video where the frames or for example, the object jumped pretty far distances between frames, you may have to adjust your search area to be sure that you are gonna search that large of an area to find this template image, okay? And on the very bottom here, we have a graphical representation of the displacement versus time of each of those tracked points, those objects. So as you can see here, since it's displacement, the initial first point is 0. And then as time goes on, you can see that the displacement of both of those features actually changes, okay? Where the head progressively gets further away from the initial position. And then we have here the ankle, which has a very interesting trend, right? The first thing it does is it actually moves away from the initial position, and then it kind of swings back underneath it, which is represented here in the graphical output. Let's say we only cared about the X displacement for some reason. We can actually go ahead and just view that here. All right, we get all the X information here. If we only cared about the Y information of the Cine file, that is also located here in the graph just by selecting Y. All right, we can take a look at the speed of the objects through time. Okay, all right, so let's actually pop this out and take a look at it. So this is what the speed looks like as it moves through time. Now, I do want to warn you that in this case, we use a single pixel tracking algorithm to do the tracking. However, there is a subpixel method to do the tracking. So in this case, when I see speed data that looks quite like this, I would encourage a subpixel analysis to see what you get. And that's covered in a different tutorial. So we can look at magnitude of speed. We can look at speed in the X. All right. So here we have a kind of smooth speed curves in the X direction. We'll look at Y. It's really Y where we see this introduction of some oscillatory behavior here. Okay. We also have things like acceleration in the X and the Y. All right. So all these things can be displayed nicely. And I mentioned you can do a subpixel analysis. So if I open the Autotrack dialog and I move it over here, I can see advanced. And here I can go from a single pixel interpolation, which is no interpolation, and I can interpolate the template in the search area by all of these factors here, okay? And this will give me a much better track. You can also, once you select subpixel, you can also choose the interpolation algorithm, okay? And if you want to learn more about that, that's in our next tutorial session in the series, okay? So I'm not going to progress forward with that. The last thing I want to mention is that you can now export this data that you tracked just by clicking export. All right, and it's going to ask me where I would like to save it. I'm going to save it to my desktop, and I'm going to call it car seat test. All right, so it looks like in this green text it indicates where it had saved to. It's saved to my desktop. So now I'm going to go ahead and open that up. car seat test, and I have a PDF and a CSV file produced from that export. It gives me the date that this report was created. It gives me the Cine file that was analyzed. It gives me the metadata of that Cine file. It gives me the contents. So for example, I had 2 objects that I tracked. It gives me a summary of the points that I tracked by showing the path in the last frame. It shows me what object I tracked. All right, and then it gives me a graphical output of my displacement versus time, and then my speed versus time, all calibrated relative to my initial calibration procedure. Okay. We also have the ability to display vibration if there's some kind of oscillatory motion inside of the paths of the tracked paths. And we will have a tutorial on this later on in the series. So if you're interested in looking at vibrational measurements, go ahead and search later on in the series. All right. And then it shows us our second object that we tracked, or our second feature. There's the template image. Here's the graphical output, displacement versus time, speed versus time, and so on. All right. And again, if you wanted to take a closer look at the data, you can pop out the graph here. All right. And you can actually choose the graphs that you would like to display. All right. So here's displacement versus time. All right. You could go ahead and you can window zoom into specific areas of the graph that you care about. Maybe you only care about this time here. All right. You can go ahead and go back by clicking the left arrow here, or go back forward. You can change the borders of this space, all right, according to these dimensions here. So you can notice that when I toggle this, I can affect the plotting behavior of the graphs. I can click on this axes button here, and I can change the name of the graph. I can change the y-axis. I can change the x-axis, and I can change it from linear to a log plot, or any choice in the dialog menu here. I can generate a legend. For example, I can put head and ankle into this plot, and I can also change how the plot looks. So I can change the labeling. I can change the lines, whether I want solid or dashed. All right, if I want to make my lines a little thicker or change how they look, I can change the color of the markers or the line if I'd like. And these are just some of the options you can do for plotting. Now you can go ahead and save this as a figure. This will save it as an image. And then you can also export this data, and it will create a CSV data of what's presented to the user on the screen. Okay. So this was just a quick look at the auto tracking feature in the Cine Analyzer package. I hope you enjoyed it. Please leave a comment or a suggestion at the bottom, and I hope to see you in some more tutorials later on in this track and measure series. Thank you so much. Bye.